Hello all my JavaScript friends, this is TheVirtuoid, aka Mike Smith, and this is our Hold the Tower game. Now last time I have gone through the tower, a gun, and a runner. Today I'm going to be taking a look at the enemies and how easy it is to create these enemies. As you can see them going on the screen, destroying my tower because I'm doing absolutely nothing to defend myself with, except for just turning my little gun around. Anyway, let's get to the code and take a look at it. So first of all, how do enemies get up on the screen? Well, it's very easy. Whenever there is a new wave event that occurs, we create a new enemy group and then we build the wave. And that's pretty much it. The building of the wave pre-builds all of the different enemies that are going to be present in that particular wave, and we use a little database here that will tell us, which how many of a certain type of monster or certain type of enemy will be appearing for each individual wave, and we'll show you that here in just a minute. As the wave progresses within the update routine, here it is, we will eventually call a schedule next enemy move, and that will go into the enemy group class and then schedule the next enemy that will occur. And then enemy group class will be able to tell us whenever there is a particular enemy that has been killed, or if that's the last enemy and the wave needs to end, and so on and so forth. So we're going to be spending a lot of time here on that enemy group list. So the first thing that I mentioned was that the enemy group is the one that creates the wave. So let's take a look at how it builds the wave first, before we do anything else. First thing we need to do is we need to figure out the number of participants in this particular wave. Now, how do we know that? Well, first of all, within a enemy enum type, there it is, called enemy types. I've lost it here for a second. We have all of our different enemies that we have defined here. Shadowlings, Frostwhip, Trollings, Mistweaver, Emberling, Stormcaller. Great names here. But by the way, I have to admit, yes, AI did generate these names for me. That's one of the great things that you can do with AI, is it can generate really pretty cool looking names here. So I set up all the different types. I set up the database here, and I'll explain this a little bit detail. The idea here within the database is that this gives the enemy type itself, but most importantly, it gives us the name. It gives us the number of hit points per that particular enemy, how fast they move, the kind of damage that they do, and the particular image that's going to be associated with them. And each one of them has an image here. As you can tell, I've got just snowman.png for all the rest of them. The one exception is if you do have animation, because if you follow this along here, you know that at least I got one of the monsters or the enemies animated, the very first one, and that's the Shadowling here. And what I've done here is that it's got an image URL, but if it also has a sprite URL, if that sprite URL, I can give it configuration pieces of information that then the enemies group will be able to use to be able to do animations, and we'll go through that here in just a second. And you can see here I got a walk, attack, and a death. Right now, I'm just doing the walk, but this is the ones that once they get to the tower, I'd like for them to be able to, hit the tower a few times. And the death one is once they get shot, they can die. We don't have that implemented yet, but we will in the future. So that's what that is all about. This enemy type here. That is also used here with the waves database, and the waves database tells me basically how many enemies are going to be within the wave. It starts off at 10, goes to 12, it ends up with the very last wave being 100 different enemies. The frequency is how quickly in between the different enemies occur. So if at the very beginning, once every 2 seconds. By the time you get to the 20th wave, you're getting basically 5 per second on there. And then these chances, this big, huge, long chance number here, are the number of chances for each of the different 20 enemies. What are the chances they're going to appear within the wave? So at the very beginning here, 3/4 of all of our enemies are going to be the weakest enemies. And that number goes down until the very 20th wave, where only 1% is. And the biggest percentage, its biggest percentage gets to be some of the really tough ones there. And you don't get the boss ones until waves 18, 19, and 20. So I use this waves database here to be able to determine the number of enemies that are going to occur, how frequently they pop up on the screen, and what are the chances of each one of these or each one of the different types of enemies are going to appear within that wave. An enemy group uses all of that to figure it out. So basically, I also make sure that it never goes back below 200 milliseconds. The key here is that the first thing we're going to do is we're going to build the enemies themselves. And this is really not much of a big deal here. We eventually just build the real enemy based upon the enemy factory. Let's pull up the enemy factory real quick. The enemy factory allows me to create specific enemies based upon the type of enemies they are. And this kind of allows me not to have to hard code toward a particular enemy, you know, saying I need you to do a shadowling or something like that, or a Mistweaver. I like that name, Mistweaver. This, by using the enemy factory, I can use either the static create enemy or create enemy from type routines within the enemy group. In this case, I'm using create from type. That way, if ever I have to make any kind of changes or anything, I just need to go into the enemy factory to make the changes. I don't have to change anything else past that point. And so the enemy factory controls absolutely everything. All the other programs, it's just this one, but if there are other programs, it would go into the enemy factory to get that particular enemy. And that eventually will give me the enemy itself. And of course, the enemy factory just, you know, does the new, creates the enemy. It creates I forgot to tell you, it creates the prizes and all that kind of fun stuff. And it just creates the enemy itself. It's not a big deal there. So that's the build wave section. So when we're doing it in the gameplay and we do the build wave, that's going to occur when we do the on where is it? On the on new wave. That's where this is going to occur. And then the other critical thing is when we do the on update. Not the on update. When we do the update, we're going to have the enemies group do schedule next enemy move. So let's take a quick look at that. Schedule next enemy move basically says, hey, you know, hey, if it is time to schedule a particular enemy, I go grab the next enemy to get the enemy launched. It basically grabs the next enemy in the list, and then it moves the enemy, and then it's set for the next. Then it sets the time for the next enemy. And what this basically does is this allows me to say, you know, okay, now once we've done this enemy, it's going to be a certain amount of time before we do the next enemy after that. And when we do the move enemy, we just basically change the position of we set the initial position of the enemy. Excuse me. Once we set the initial position of the enemy, we use a certain routine called tweens within Phaser.js that basically says, okay, I'm going to move this particular image from its current location to tower X and tower Y within a 500 second animation. And I just realized that is in error because that doesn't take into account the speed right now. That'd be one of the things that we'll update later on, but it doesn't take into account the speed of a particular enemy. So this is where we'll change it if we had to add an enemy. If there is any kind of updates or anything, especially if there is some sort of damage to it, then I update the health bar. If it is complete, then I emit the enemy reaches tower, because if it does get completed, that means the enemy has reached the particular tower. If there is a destroy event, if I tell it that it's been actually destroyed, then I take care of everything I need to take care of to destroy the enemy. And that's pretty much really it for the enemy. There's not really a whole lot here. Once the tween has occurred and there is a missile strike onto the enemy, that's when it's going to call there's the handle event there. That's when it's going to call the missile hit enemy. And so when the missile hit enemy, we're going to go to the on enemy reach tower, on enemy destroyed, on missile hit enemy. And at this particular point in time, we tell the enemy to take damage. If we emit the event enemy destroyed, then the enemy gets destroyed. When the enemy is destroyed, we kill the tweens, we kill the enemy, we drop the prize, and we end the wave if that was the last enemy. And so that basically is really all there is to the enemy. There's not really a whole lot to it. The really key important things is this enemy factory. I'm using this enemy factory to control the creation of every one of the enemies that are listed inside of this enemy type. I'm using the enemy type to be able to say whether it's just going to be a simple graphic or if it's going to be an animation on there. Oh, and let's take a quick look at what the animation is all about. So in the enemy animation, there is a specific, or in the enemy type, excuse me, there is a specific routine here called create animations. And this goes through that if there is an enemy sprite, which right now we only have, as you can tell here, is just like one enemy that has a sprite. When there is an enemy sprite, we use this. We use the special anims routine within Phaser.js to be able to create a particular animation, and we give it a particular key name. Now, the idea here is once we have done that, is that when the enemy is created, after the schedule next enemy move, when we first start to move the enemy, the move enemy then basically positions the enemy in a certain position, makes it visible true, but then enemy UI play animation walk. And if there is no play animation on the UI section, then it doesn't do anything. But this UI here is a specific pointer to the Phaser.js section. This play animation section, the enemy.ui, just play animation. Remember, within all of these classes here, you have the basic class itself and then the UI class, which points to the Phaser.js implementation. So I should expect to see a play animation routine on my UI, which I should do, and yes, there it is. This will actually play the animation. It grabs the enemy data, and then it tells it to play it. And that's it. So that's how the animation works. The animation is extraordinarily simple. So again, the real key here is that we create the animations, and I think that is done in the gameplay. Yes, it is during the this is during the create section where it builds up the game. This is where we actually build up all the different animations. And then all we have to do is we return the new enemy group. We return the new enemy. When we first move the enemy, we're going to place it, set it visible, and then play the animation. And that's pretty much it. And that's all there is to the enemy. Thanks for watching. Subscribe to this channel to view more videos. Click on the like button on this video and visit us at TheVirtuoid.com. Also, support us on Patreon, where you can get access to member-only videos. Links are down below. Again, thank you very much for watching, and keep on coding.